on. There we go. So last time I saw you, we were doing 1.5, not 1.5,
You're
which
not
was,
presenting.
oh, thank you for telling me. I was wondering why I only got one little thingy there saying I was sharing my screen. It was just the Screencastify one. There, now you can see me, right? Waving at you from the big screen. So we're doing 1.5, which is still analyzing the graphs of functions. Dang it. Sometimes I like when it helps me, and sometimes I really don't. Analyzing. I feel like I spelled that wrong, but I don't even care. And it's just a continuation of what we were looking at the other day. And the other day we were basically looking at graphs and trying to figure out the domain and range, right? We were looking at it. What else did we do with that? I can't find. We found the zeros. We did the vertical line test to see if something was a function. And today we're finishing up with. We also did increasing and decreasing, right? And you could look at it and see everything. Relative mins and maximums, relative minimums and relative maximums are literally what they say. And there's a nice complex definition of relative minimums and relative maximums, but it's so much easier if I just show you minimums and relative maximums. So if I have a graph, look, just like that, I have a graph, right? And I graph something on that graph, right? Say my graph is like every one of these turns has a high point or a low point, right? Forget this one. It was supposed to be a line like that, right? Every one of these points at a turn is considered either a relative min or a relative max. It is either a minimum point or a maximum point on a graph. Check this out. The ones that sit low are clearly our minimums, right? The ones that sit high are our maximums. And for your assignment, it tells you specifically to use graphing calculators to figure out what they are, the relative mins and the relative max. And so we are going to do that in the form of Desmos. Now, if you just look up desmos.com and you can find a graphing calculator, and all you have to do when you do that is plug in the equation, right? So if I look at, say, 3x squared minus 4x minus 2, right? The only turn I have on this graph, because this is a parabola, right? It's a quadratic equation, which makes a parabola, is right down here at the bottom. You're going to have a minimum, right? Because everything else is going up. And so when you're looking up the relative minimums and the relative maximums for your homework purposes, all you're going to do is take whatever function they give you and plug it in here on your graphing calculator, and you are going to plot the turns, right? And it'll probably, I think it tells you to round it up to like the nearest decimal, but literally that's all there is to it. You're just plugging the equation in as you see it, right? And you're going to find your turns. In this case, we have a minimum, right? We have a low point. If I had minus 4x squared minus, say, 7x, let's go, oh, sorry, x shift plus 3. Now, when we look at it, we're going to have a maximum, right? We're going to have a maximum point there. And if I roll my cursor over it, it's going to tell me what that point is. So, like I said, when I said this was easy, I meant it was pretty easy. I think even for anyone, I don't think it's just easy for me, right? You're plugging in the function exactly as they offer it to you, and you're just finding your high points or your low points. And that's really all there is to it when it comes to minimums and maximums. So, really, nothing extreme. I wouldn't steer you wrong on that one. The next bit that we're going to be talking about is, I think, the hardest bit of this section, and it is called the average rate of change. Because in pre-calculus, we start to introduce the more complex definitions of things that you already know. Because they say, well, the average rate of change is, let me give you the formal definition of this. A function value f of a, oh no, sorry, I'm on the wrong spot. That's relative max and minimums. The actual rate of change, let's say, is equal to f of x2 minus f of x1 over x2 minus x1. That is the definition of it. And basically what it's saying is you've got the change in y over the change in x. And this looks complex, but really you guys have been doing this for years. It's essentially figuring out the slope of the line. That's really all we're really finding out. And so if I have, say, if I want to find the average rate of change, find, because this is how it's going to be asked to you in your homework, find the average rate of change. From x1 to x2 for f of x equals, and it's going to give us a function. In this case, the function is going to be x cubed minus 3x. But it's going to tell us what our x1 and x2 are. So in this case, we've got an x1 that's going to be equal to negative 2. And we're going to have an x2 that's going to be equal to negative 1. And we'll do it with another set of numbers after this, just to show you kind of how it works. But they're saying, okay, well, what is the rate of change from this x value to this x value? What is the slope? Well, we have a formula, right? And if we think about this, x2 and x1, those are pretty easy. We know what those numbers are. What we don't know is what f of x2 and f of x1 are. But those are just the y values when you plug in these x values. So if you think of it in terms of a table, right? We can go x and y. We know that our first x value is negative 2, and our second x value is negative 1. So what that means is we're just going to plug those numbers in here. So for our x1, for our f of x1, right, we're just going to plug in negative 2 everywhere we see an x. So we would have negative 2 cubed minus 3 times negative 2. So negative 2 times negative 2 is 4. But if we multiply it times another negative 2, we get negative 8. Negative 3 times negative 6 is, times negative 2 is positive 6. And then negative 8 plus 6 is just negative 2. So when I have negative 2, my y value is negative 2. That means this f of x1 is just the number negative 2, that whole thing. To find my other one, my f of x2, well, all I'm going to do is plug in negative 1 everywhere there's an x. So here I have negative 1 cubed minus 3 times negative 1. This becomes negative 1. Negative 1 times negative 1 is 1, times another negative 1 is negative 1. Negative 3 times negative 1 is plus 3. And this just equals positive 2. So these are my x's, right? This is my x1. This is my x2. Well, this is my f of x1. And this is my f of x2. Right? So all we have to do is plug these numbers in once we find out what they are. I told you this was difficult, but it's not difficult, right? At the same time. I mean, it's step heavy, but it's not difficult because literally it's the slope. Once we find all we're using is the slope formula. We're taking the difference between our y's over the difference between our x's. So we're going to go 2 minus 2, right? Because we've got f of x2 minus f of x1 over x2, which is negative 1, minus whatever x1 is, which is negative 2. This becomes a plus, so we have 4. This is negative 1 plus 2, right? Which is just 1. So our average rate of change on this is 4. Technically, it's 4 over 1. If we were thinking in terms of slope, it would go up 4 and over 1, right? But it's just a slope. It just means plug in those x's and find out what the y's are.
I thought it was just going to be like last Tuesday. Pretty simple, straightforward. It's a lot.
This is as hard as it gets, though. This is the hardest part of all of it.
Yeah, that's a lot more.
We'll do one more together using the same equation because I didn't write down another equation. But what if we want to know? We'll look at the same points, right? We'll look at the f of x equals x cubed minus 3x. It doesn't matter what the equation is, right? It's just how we're going to find our y. And say we want to go with x1 equals, what did I write down? 0. And x of 2 equals 1. Now I don't have to look down at it anymore. So we know what our x values are. We need to find those y values that go with it. Right? So I'm going to go x, y. So if I plug in 0 here, this whole thing is 0, right? If I plug in 0 for my x value, 0 times 0 times 0 is just 0. Minus 3 times 0, which is 0. The whole thing is 0, right? I'm not even going to do the math on it because if I plug in 0 here, everything becomes 0. Does anyone not see that? I'm trying to look at Jameson's face to see if he doesn't see it, so I can.
I'm like the reason here. Just look at it. That's
how I know because everybody else is just a picture.
It's a bad idea. I was struggling to figure out range yesterday, so I don't think I should be compared to everyone else.
I know, but that means if you don't get it, I now have to keep going.
So someone's really below me. They're struggling.
So. Anybody, tell me, come on, give me a little feedback in the chat box or something. Do you get it? Do you see where it's 0? Do you see what I'm doing?
Sense, but I see where it can get confusing.
Thank you, please. Thank you for some responses. So once we know what the 0 one is, we're going to figure out what our x2 is. And our x2 is we just plug 1 in, right? So we'd have 1 cubed minus 3 times 1, which is like saying 1 minus 3. Which is just negative 2. So when we plug in 1, we get back negative 2. And what we're looking at is the difference in our y's over the difference in our x's. So if I want my average rate of change, I'll call it ARC. It's my arc. That seems weird because arc is an actual mathematical thing, but we're just pretending that average rate of change means arc, right? I'm going to take -2 minus 0, right? My change in y's over my change in x is 1 minus 0, right? -2 minus 0 is just -2 over 1. And so this average rate of change would be -2. So not super difficult once you figure out what your y is. So basically they're going to give you the x's, you're going to plug them in and find the y's, and then you're just going to do the slope formula on them, right? Your change in y over your change in x. The last bit, because that was so much already. So we're going to do this last little bit, and then you're going to hate me, and you're going to be like, Miss Hoy, you lied. You said this was easy. The only thing left we have to talk about is even and odd functions. Here's the thing about even and odd functions. Outside the parameters of this class, you will never care about even and odd functions.
Why are we learning this?
Because I got to teach it. Because they're paying me. They're paying me. But it's something that you should understand, right? Because you can tell by knowing if something is an even, odd, or odd function, what kind of symmetry it's going to have, right? And what I mean by symmetry is an even function would be symmetric relative to the y-axis, right? That means everything happening on this side is also happening on this side, right? They're like mirror images of each other on the y-axis. That would be an even function, right? An even function is symmetric with respect to the y-axis. An odd function, and not all functions are symmetric, but an even function would be symmetric with what we call about the origin, right? Which means that it's going to flip it on over the y and then over the x, or over the x and then over the y. But you notice that, like, if I flipped, you can't see what I'm doing with my hand. I'm like on the screen with my hand. But if I flipped this piece over here and then I flipped it again over here, it would be like so it flips over both. Yeah, so
I was about to run it off of my phone. This is at 1%, and my phone's at 2%. We're not rocking good over here.
Do you have chargers for either of them?
I have chargers for both of them.
Bumper stickers.
This would be an odd function. Now, there's always the opportunity that they're not symmetric about either. But algebraically speaking, we can determine whether or not a function is odd or even. So an even function y equals, I should have just put a function, y equals f of x is even when. An even function, y equals f of x, has for each element in the domain. So any x value you can put in for each element in the domain. I am trying to teach right now. You need shush. You're distracting me. For each element in the domain. So that means all of your potential x's, any x that you can put in to the domain of the function f, f of negative x would equal f of x. What does that mean? Well, looking at, yeah, he needed to be shushed. I'm going to write down the one the definition for an odd function now, and then I will give you examples of both. An odd function y equals f of x has for each element, I have to write all this again, has for each element of the domain of f. My hand is cramping. I've had a busy writing day today. F of negative x equals negative f of x. And you're like, what's the difference? Well, there's a negative. That's a difference. But let's look at some samples. Like this one, if I plug in a negative, if I plug in any value for x in a negative x, I should get back the original f of x, right? What we started with. Here, whatever I plug in, I should get back a negative. What does that look like? We're going to use g of x. I don't know why, but the book went with g of x, which doesn't matter because it's the same thing. It's just the name of a function. So if we have g of x equals x cubed minus x, and we need to determine whether or not this is an even or an odd function, what we are going to do is we're going to plug in negative x into our x values. We are going to find g of negative x and see if it pops this back out, right? So what that means is right here where I have x cubed, I'm going to put in negative x and cube it. Minus x, well, that's just negative x. And we're going to see what we get back out. Well, if I look at negative x cubed, negative x times negative x is x squared, right? Positive x squared. But if I multiply it times another negative x, I get negative x cubed, right? Negative times negative x gives me positive x. And if you look at that, you're like, what the heck's going on? But I can just pull the negative out. I could factor that negative out, right? And I could write negative x cubed minus x, right? Which is what we had here, which is this, right? We've got our negative on the outside. We got our original thing back with a negative on the outside, which means that this is an odd function. What it tells me is that this is symmetric about the origin, right? It's the second one. Now, I could have told you that because it's a cube, and cubes are always symmetric about the origin if they're symmetric at all, right? Just like I could tell you that anything with like an even degree is going to be, if it's symmetric at all, it's going to be symmetric about the y-axis. So this is what an odd function looks like. That's a good example of an odd function. What if we have, let's look at a different color. What color should I go? I'm going to go gold. I'm going to go gold, and I'm going to use h of x. Right? If I have h of x equals x squared plus 1, right? I'm going to do the same thing. I'm going to find what h of negative x is. It means I'm going to plug in negative x for all of my x values. When I square negative x, I get x squared plus 1, right? Well, what did I start with? I started with x squared plus 1. So when I plugged in negative x, I got back what I started with, right? Which means that this is an even function. Does that make some sense? Was it super confusing? Literally, you're just taking whatever equation they give you and you're plugging in negative x. If you get back what you started with, it's an even function. If you get back a negative of what you started with, it's an odd function, right? Here we got back exactly what we started with, right? Except for we have this negative in front of it. So it's odd. Here we got back exactly what we started with. So it's even. And what it tells me is if it's odd, if we get that back and it's an odd function, we know that it's got symmetry or it's symmetric with respect to the origin, right? That means it flips over both axes to the origin. In an even function, when we get back exactly what we had, it is symmetric with respect to y-axis. And if you think about it, it kind of makes sense, right? I wanted a little graph. I can make one, right? If I have a graph, and I'm going to graph a parabola like I had before, right? I got something going on here, and I got something going on here. And we know it's a parabola. We know it's symmetric on both sides, right? So think about what we're doing here. Here we're saying for every x value that I put in, if I put in its opposite value, I'm going to get the same y value back, right? It gives me the same equation. And that makes sense because if I put in, say, 3 for x here, I'm going to get a value, right? If I put it in at -3, I'm going to get that exact same value on the other side. Does that make sense? Does that help a little bit? When we talk about something being symmetric about the origin, right? Say, I'm going to do like that, pretend this is symmetric. We're changing the signs of both, right? We're changing the signs of x and y, right? So the whole thing becomes negative. Every value becomes negative. So if I have x equals 3 here, right? Say this point right here. Let me put it in a different color. Say this is 2, 2. If I put in -2, I would get -2, -2, right? It's going to change both of those. Does that help a little bit? Here, if I put in something at 3, I would get a point 3, we'll call it 3, 2, right? Here, if I put in something at -3, I'm going to get a point -3, 2. Not that you could read that point that I just drew, because right. So you can almost look like if you were looking at it in terms of a graph, you could just see, well, did both signs change? Did everything stay the same, but both signs change? That's an odd function, right? Did everything here stay the same except for the sign from x change? That's an even function, right? So that should help a little bit. Anybody have any trouble with any of that? I highly recommend playing with it in the homework a little bit. I think there's only like 7 homework problems. And a couple of them are just look at it, like plug it into Desmos and get your solution. Pay attention to how they're asking you to enter the solution because it might tell you to round up
Like
or
those
down.
parentheses.
Yeah. The next part is just going to be finding a rate of change. I think I only gave you 2 of them, and I picked the 2 easiest ones that I could find of the whole group. right? I didn't go into anything crazy for you with the rate of change problems. And then I gave you 2 of these. So I think you have 3 where you plug it into Desmos, and you have 2 where you have to find the rate of change, and then 2 of these where you have to determine whether it's odd or even, and its symmetry, right? Does anybody have any questions pertaining to any of this? I guess I can stop the recording now.